Thanks everybody for being here in the shade. I hope it's not too hot. So let's get started with the talk. Bootloader Crimes, building disposable Windows VMs. What is this all about? So a bit of motivation. Why are we even doing this? So I use Arch, by the way, on the desktop even. But yeah, as mentioned, sometimes you cannot get around Windows, right? Maybe you have some application that you cannot run in Wine, it doesn't work right, or you maybe don't even want to run it on your main system because it's some not very trusted software, and you just want to analyze it, poke at it, or you have some proprietary software or hardware that requires Windows software that you maybe want to reverse engineer and make work on Linux. This happens to me, and I think at camp it probably happens to most people, but only sometimes. You don't need it every day, but every so often, once every 3 weeks or months even. But then sure, use a VM, right? We have the right tools, but I guess maybe show of hands, who has a Windows VM that just lies around that they haven't booted in a while, or yeah. And when you boot it, is it a keep a hand up if it's a pleasant experience? Yeah, the one guy in the back, he has it all figured out. So yeah, you boot it, and then it wants to update, or I don't know, some new features have been pushed that you now have to deal with, or activation has expired, or generally something else has broke, and sure, you can keep a Windows VM around, and if this is maybe your day job, and you maintain it, or have lots of snapshots, whatever, this might be pleasant, but for occasional use, maybe not so much. So sure, just do a fresh install, right? But that for occasional use, it's a lot of quick clicking, waiting. You need to configure all the things, install all your tool software again, enable file extensions. We've probably all been there, and declutter, remove whatever useful features Microsoft added in the meantime. But we're hackers, so when in doubt, automate, right? And so this is what this is all about. So there's some existing installations, right? People have instrumented or automated Windows deployments. There's open source, more or less open source solutions. There's Box Starter, which is some tool that you can put on a Windows machine that is already installed, and it will continue set up your environment. HashiCorp Packer, it's used for building images for Vagrant, if you've heard of that. It can provision Linux, but they also have some very nice templates on provisioning Linux. You could remaster an ISO and put some answer files in there, so it installs itself. As mentioned, answer files. Ansible has support for it, so you could write some playbooks, or Foreman deployment solution also does it. But I looked at all of these, and some of these they have some nice concept, but none of these really worked for me. So obligatory XKCD reference. It's already so much stuff, but we need more, and surely this will fix all, at least my problems. And yeah, so let's see. So some design goals, right? So I want it to be really easy to use. I don't want to write YAML or JSON or whatever. I just want to use a website, right? So I can send it to someone and they can use it without installing any software or cloning a Git repo, right? I want to import all the settings, select some checkboxes about features, maybe configure my username, time zone, whatever, and maybe even save and load a preset or even share a preset with a friend. Targeting. So I've been working on this project on and off for a while. So initially, maybe it was Windows 7, 10. These days it's 11 because it's the latest release and the one that will be supported for the longest. And hypervisors, I work with VirtualBox, QEMU, but surely it should run on all of them really. So the question is, how do we do this? We could just build an image on a server, right? Have a beefy server that can create an image, provision it, and then we download the final image, right? That's maybe fine for myself, but it runs into some issues, right? So there's obviously IP copyright troubles. If I offer a finished Windows image, there's intellectual property by Microsoft. They might not be so happy with me distributing that. Also, it doesn't scale, right? It's rather resource intensive. I need a lot of resources to provision VMs on my server. The images I will ship will incur a lot of traffic. So that's not ideal if I want to, have many people use it. So the idea is here, just run it locally, but have it provision itself locally. But how do we do that? So the first step, this we can do in your browser, right? So you fill out some form, and from that we'll generate some configuration file, and then we'll just inject that into a very tiny, like 15 megabyte disk image. Just copying it in there with an array operation, and we'll also generate this OVF like manifest file. It's an XML with some your VM's name and memory size, whatever, and then we'll just throw these into a tar, and that generates an OVA file, which is just this, appliance container, and you can import it in, I think, VirtualBox, VMware also has support in it, or, alternatively, you could just get the disk image out of there again and maybe lose some of the metadata. And this we can all do in the browser. On the client, we don't even need server code. We can just, serve some static files, few megabytes, and then you get this OVA. Okay, but what is in there? So you boot it, and this is the initial state of the disk. So you see we have like this little boot partition. It has a bunch of stuff in it, and we have like an empty NTFS partition. So there's a kernel in there. We can boot it with some bootloader, syslinux in this case. And in this case, it's just some stock Alpine kernel precompiled for VMs. You could do your own with build root and make it even smaller, but taking binaries from Alpine is just sufficient, and we remix it a bit. There's an initial RAM disk image in there that's very tiny. It's just busybox and curl essentially, and some other configuration files and shell scripts. And you can see highlighted your user configuration that we injected in the browser. So that is the only part that is unique. And so, yeah, you boot this, and you see, okay, it's a very minimal Linux thing booting. There's some tiny user space, and it drops you into it automatically executes a shell script and does some things. Okay, so what does it do? Yeah, so it does some DHCP, sets up networking, sets up your basic stuff that you need to run. Drivers, devices, mounts the disks, whatever. And first things first, well, we need to get a Windows installation, right? We didn't want to ship that, so we need to get it from somewhere. Thankfully, Microsoft has a evaluation image for, well, these days Windows 11, but I think they also have it for Windows 10, even still online. And you can just freely download that if you know the URL. So we just fetch that with curl and put it on into our scratch space, right? And we can then also like validate the checksum to see that it's legit. So in the next step, we start to mount it. We extract some things. So you can see on the left, we extract some boot files and the install file. So the install file is basically what contains the data we need for our Windows installation. And the boot files are kind of this live installation environment. So you can see these are in WIM files. So what are WIM files, really? I mean, maybe if you've dealt with provisioning Windows before, you've seen these. So Microsoft uses these for installing and deploying operating systems since Vista. So they saw, copying hundreds of thousands of small little files from install media to the disk is cumbersome. Let's just package it somehow. So the title says, it's an imaging format. It's not like UDD disk. It's not just blocks from a block device, but it is files, so it's rather more like a zip or a tar, really. But it has some additional features, right? It has all the metadata, all the Windows security descriptors, whatever, fancy NTFS special file types, whatever, that can all be persisted into a WIM. And you can have multiple images, right? So maybe if you have install media that has different versions of Windows, right? You can all package them into one WIM file, but you can deduplicate files because these versions, they will have a lot of the files that are identical. So, it'll just be pointers to the same data, essentially. And, you can compress it in various ways. You can also split it, I guess, if you want to keep your WIMs on FAT32 or whatever, or your another file system that doesn't support arbitrarily large files. You can split them up. Also, you can boot them, the installer, or if you have a recovery system, you can directly tell a bootloader or one of Microsoft's bootloaders to find the right files in this WIM and then boot into it. And yeah, you can manipulate it on Linux, for example, with WIMLib. Microsoft in Windows also has some tools for it. And I think, if you have on Linux, if you have a package manager, then you can likely also use that. Yeah, in the end, it's really a fancy zip file, more or less. So okay, now we have these Vim files on disk. We need to do a bit more. We have the user configuration and some templates. So from these templates, we generate some more files that are used. The answer file and maybe a PowerShell script that are used later during the install. And then we fetch Vimboot. This is from the IPXE guys, and it's basically an open source bootloader that we can use to, as mentioned previously, we can boot Vim files. So this is a component that we can use to boot into this boot.vim from the X4 partition, even. And there's some other files in there. We have an ini and a bat file, which are used in the next stage, where we actually boot into that that installation environment. So we tell syslinux, hey, don't go to the kernel anymore. Go to Vimboot instead, and please boot these files that we dropped on the X4 partition. And we end up in the Windows so-called WinPE, Windows pre-installation environment. This is, if you pop in install media, what you see. And instead of the installer, you just get a shell, and the shell script we have in there gets run. So what do we do in that shell script? So we continue the installation process, because we now rely on a few tools that are just available from Microsoft, need to be run in a Windows environment, right? So essentially, we now have switched after rebooting from the live Alpine into a live Windows environment, right? So first thing is we get rid of that X4 partition. We did boot from it, but now we're running from memory, so it doesn't matter. You can do it with disk part. It's like fdisk, but for Windows. Or for Microsoft, it's a command line partition editor. We create a new partition for our final installation. So it's only occupying half the space of the image right now, because we still have our scratch partition. We create a file system and then mount it. So mount it under W like Windows, and then we start doing the deploy, right? So with this dism, you say apply image, and that is essentially unpacking, right? It just takes all the data that is in install Vim and just shovels it on the partition, right? And you can see the typical directories appearing that you would have in a Windows installation. And we also copy our answer files over, so they reside on there. And we can delete the scratch partition and then grow the other partition. And now we are essentially in a stage where we have the disk almost ready to use. It's correctly partitioned. We have one giant Windows partition, an MBR partition table for Windows, and all is well. Well, this is not really a bootable system yet, right? So if you just drop some files on a partition, your computer will be like, oh, that's fine, but I don't know how to run this. So how does this usually work with Windows, right? So we have the like modern day, the UEFI way, and the legacy way, and somehow the firmware of your mainboard runs, or your system runs, and we need to somehow load the kernel, right? And how does that happen? So with UEFI, it's comparatively easy, right? You have a EFI partition. It's fat. There's a PE file on there, this one file. It'll get run, and then it can it loads another load file, and then eventually loads some stuff and loads the kernel. It references this BCD database, which is boot configuration data, right? So it's kind of like a Windows registry hive, but comparable to your grub config, right? There's some, if you want to boot in safe mode, or disable I don't know, certain features like driver signing, or boot Windows in weird special modes. That is where you would configure that. But we're not using that, right? We're in a VM, and we don't have EFI set up. It's just a normal VM, and we don't have an EFI partition. We just have one giant NTFS partition. We want to boot with BIOS. How do we do that? So you can do this command, so bcd boot. This will install a bunch of things. It will install the boot manager to disk, and also populate the bcd configuration on your Windows partition. Okay, so we have that set up, and we have another command, dissect, and this will basically set up the earlier stages, right? It will write the MBR, which is at the very beginning of disk, and it's rather tiny, and it will also put secondary loaders into the partition itself, right? The volume boot record, or partition boot record, whatever you want to call it. But this resides in in some free space in the NTFS partition that we have. And this will get populated by this command. And yeah, we just call them in our pre-installation environment. And then we have a bootable system, right? So Microsoft, we just reboot, and Microsoft calls this the out-of-box experience, right? It's the first time you boot. The system will reboot a couple of times, do some setup, and yeah, get you going. So now our XML answer files come into play. Usually you have these dialogues. We don't want to create an online account, whatever. But the answer file bypasses all that. We picked a keyboard layout, we created a local user, set up a host name, whatever, and at the end we'll invoke the PowerShell script. In the PowerShell script, what can we do? Well, just some examples, right? We can configure all the annoying things, and it does things as instructed to by the web application. So it sources the configuration you put in the browser and sets some things up. There's some links to things. You can install software with Chocolatey, whatever. And at the end of the day, you'll end up at the desktop. This takes about 10 to 15 minutes, depending on the internet connection. If you have the ISO locally, it's faster. If you choose to install updates and it has to reboot a bunch of times, it can take quite a bit longer. But 10, 15 minutes is a good estimate. But you don't have to do anything during that time. So why is this bootloader crime and a truly cursed install? So as mentioned, we're installing Windows 11, but we are doing legacy boot, right? We don't have an EFI, we don't have secure boot, we don't even have a TPM. As mentioned, it's a classic partition table. It's not a GPT partition table. We might even not have more 4 gigabytes of RAM, which is I think the minimum, or a compatible processor. Why is that? Well, it turns out the project, it started some time ago, and I was trying it with Windows 7, and that worked just fine. And then I switched it to Windows 11, and it continued working. And it's like, that's interesting. Okay, so yeah, some more. It seems really the installer enforces a lot of stuff, and there's tutorials on how to bypass these checks in the installer. But we don't even use the installer, right? We just boot into a live environment and unpack the files normally. So yeah, further than also the install media is EFI only, so it won't boot on legacy boot, but it doesn't matter. We use syslinux and Wimboot, so we bypass that. And very interestingly, the dissect tool still has MBR support. So I guess, not entirely sure why, but I guess, Microsoft is strong on backwards compatibility. So they probably left it in. It's useful if you want to use Windows 11 tools to maybe repair a legacy install of an older version. And yeah, as far as, the whole bootloader chain, the kernel, the handover, it's mostly, it seems the format remained compatible in the end. It's just a PE file. That's massively simplifying it, but it seems both boot chains, the legacy and the EFI ones, still work. So of course this opens up wild speculations that I won't get into here in this talk. Surely some of this, parts of this is technical decisions. Things like secure boot, having a TPM makes sense. If you want to run this in production, don't run this in production, right? Run this for a research VM or whatever. Maybe some of it was also business decision. So there's some future work quickly to get into. Need to test this on more hypervisors and enhance how you can configure it, how you can customize it, maybe allow the user to insert some hooks in the web applications to do more advanced stuff. Also, in theory, you can do this on bare metal, right? You could put it onto some flash drive and have it not install on its own block device, but on some other block device. That's just minor tweaks. It would be really cool to make this an even more weird install, to enable the pre-installation environment entirely, either run dism in Wine, or maybe use even Wimlib to deploy the files and then figure out how to install the bootloaders. Maybe also install updates from the pre-installation environment, so it's quicker. Also maybe even going to UEFI and a GPT disk, just MBR disks, they have limits in size. If you want really large disks for your research VMs, you're kind of limited by that right now. And yeah, with the bare metal thing, find some really obscure hardware to make this run on and have some fun with it. Yeah, that's it. That's a GitHub repo where the code lives, and it's not up there right now, but I'll be sure to push it, later in the day or the following days. And yeah, you can hopefully then try it out directly there. I'll put a link in to try out the UI online. And yeah, if you want to reach me, I'll be around on camp, or you can get all my contact details online. That's it. Hope you enjoyed it.
Yeah, many thanks, Philip, for this interesting talk. Unfortunately, there's no more time for questions left, so thank you again.